A very good morning, good evening, or good afternoon from wherever you are connected remotely. Today we are going to what I'm going to talk about in my presentation is about streamline security with shift left, a cloud approach. What is shift left? What is cloud approach? How we are gonna see streamlining those. We'll be seeing in the next 30 minutes before I jump into the real uh, the real butter of this topic. Very quick introduction about myself. Myself, Avinash Jain. You can find me on various social media with handle as Logic Bomb. I'm a security engineer currently working with Microsoft as a product manager for identity security. I'm a cricket player by heart, and I am a tech blogger at Medium with handle as Logic Bomb. It's also publicity for my blog, so you can go there, logicbomb.medium.com, where you can find various stuff that I write about security related to compliance, privacy, data breaches, various hacks that I did in the past. All are there. You can find and learn from there. Uh, I call it break stuff to learn. So I've been doing this for past 6, 7 years. I try to break stuff's application logics and try to learn out of it and share that learnings with the community. I'm also a cybersecurity speaker. I've been speaking at various security conferences, DEFCON, NULCON, B-Sides, and various others. And now I got opportunity to talk to talk at RootCon. So thanks a lot for everyone who are attending this and listening to me. We will proceed ahead and see what is shift left actually means. So you might have seen this word shift left, uh, in the title, streamlining security with shift left. Before we jump into what is shift left, let me create a base of why we are going to study what is shift left. So in this agile world where there is continuous iteration of development testing happening throughout your SDLC cycle, throughout your different phases of your SDLC, there's a constant collaboration amongst different stakeholders which are involved. Uh, they are product managers, the security team, QAs, developer, engineers. There's a huge collaboration which involves multiple and diverse stakeholders, and you will see that improving continuous improvement is happening at every phase or at every stage of your SDLC. Every release now it's getting more frequent than ever. Engineers are releasing their bug fixes, patches, features, or whatever in a very frequent manner as it used to happen than before. All of this actually makes a chance of your potential security loophole to occur or to become more and more real. The chances of having of of coming or maybe getting those loopholes, security loopholes, become more real when we talk about in a startup world where they shift development of your application, where this more code is written, where this more releases are made. All of this in real sense make these unknown dependencies or vulnerabilities or security loopholes become more real at each step of your SLC. And what happens when all of this become huge? It leads to consuming more time and effort for your engineers to fix it, and it also delays your release timelines. Since now you are doing security testing at the end of your at the end of your cycle, those security loopholes which were coming from every stage of SGLC now is getting fixed at the end, and now it's being that time and efforts now is getting spent at the end of the cycle, and all of this makes your release delays. It leads to more consuming more time, effort, of different all the stakeholders. It basically like you are revising your SDLC cycle again and again. If we apply a Pareto principle here, which says that about 80% of your security bugs or any bug is fixed in that 20% of your software development. Now, what about that remaining 20% of bug? Then that remaining of 20% of bug is fixed in the remaining of phases of the ICLC cycle. And this is what brings us to the need of shift left, or the need of scaling security with shift left approach. Now, what is shift left? In this slide, you might be seeing a traffic light which is getting turned red. and they send and the picture of rainbow where there's red color, there's 7 colors, and the red color is something which is common in both of the picture. I wanted to ask you, but the red color is something which is common in both two pictures. Now think why that red color is common, why I am emphasizing on red color, or why red color is used in traffic light to hold the traffic, or why red color always comes at the end of the rainbow. The reason is pretty simple. If you talk about physical reason, it says that because the red color has the largest wavelength. That's that means that it can travel to a furthest distance. And as you move towards the red side, as you're moving away, moving right, that means you are moving right towards them and you are moving away from the source. And when you come closer to the source, that is means you are moving to the left side. Shift left means, in a very simple term, in a very layman language, is bringing anything close to the source. So when we talk about SDLC, when we say shift left, that means we are bringing something close to the source from where the future is getting created or discussed or brainstormed. So that is means shift left. We bring our security testing or discussion or whatever close to the source of the future of the release or uh, of the SDLC cycle. Now this is another example of shift left. So most of the people who are from computer background might should have understood what is left shift operator. So when you apply a left shift operator to a number, you will find the resultant quantity increases to a large amount. For example, in this picture, when I apply a bitwise left shift operator of 2 to number 25, the resultant become very high. The result become 100. Now I will combine both of the definition to create what exactly we achieve by doing shift left. So shift left in security refers to when your measures are implemented to ensure that security concerns which are taken into the consideration during the whole life cycle of your application or application development, they are taken not at the end of the process, but they are taken throughout your SDLC steps. The goal of shift left security is to make sure to identify and resolve potential security vulnerabilities that may occur or that can occur in the earliest phases of your SDLC cycle, and where these issues are less expensive to fix. Some of the direct add-ons that it provides is that it gives you a much better opportunity to see the security outcomes occurring in the product sooner, because now you don't have to wait at the end of the SDLC cycle to do your security testing. Now you are integrating security at the early phases, and you can see the security outcomes much earlier. It involves requirement gathering or providing suggestions to the product team or advices at the early stage. It also obviously directly will save a lot of effort and time and the overall cost of products of your product, rather if we are doing it at the end of the cycle. Now because we are integrating the efforts at the each phase, we are saving our time, our efforts, and the overall cost of product, which were getting very huge when we're doing security, when the product getting shipped to the production environment. It also brings the improved testing and monitoring of your future, or of your release. It also responds to support your security drift detection. It also helps to improve the security adherence among the engineers and adoption, because now because security is from the starting of the SDLC, people will not be get shocked, when their release is going live, and when you are involved with your security team, and everyone is like, oh, we never know that it is going to happen, and now it is delaying our timeline. So it obviously create that kind of mindset among the engineers that yes, security will be from the starting. We have to keep something related to security in our mind and adhere to that, or it increases the adoptions among the engineers. This brings me to the quote which says that security should not be treated as an afterthought. It should be brought as close to your source, to the engineers, as early as in the SDLC cycle. And when we bring, as I said, when we bring something close to a source in this context, we're bringing security close to the source. That means we call it shift left security. Now, when we were studying about bitwise, when we see the slide of bitwise left shift operator, and I said that when you bring something close to the source, something when you apply shift bitwise left shift operator, the result of quantity become very huge. Now, bringing that meaning into the security. So when you bring security close to the source, from this curve you can actually see your overall uh, cost of the product security drastically decreases, and the effectiveness of your complete flow increases. So when you bring security close to the source, that is when you do a shift left, what it does, it increases the effectiveness of your complete flow, and it decreases the cost of security or cost of your product. So as you move away from the source, the cost of security or cost of your product actually increases rapidly. So this is what uh, the main outcome of bringing shift left into your agile cycle or into the culture of your company. Now we talk about, we have seen what is shift left, why we are doing this, but how to do this. The main question is this: how we can make sure that each and every bug which might occur in the early SDLC cycles are getting uh, you know found out by your security team or by your engineers. In order to do this well, the most logical part which can be checked are the source code. Here we will be talking about how to achieve shift left during your release in your CI/CD pipelines. We'll be seeing how to integrate security in your CI/CD pipelines if you are over AWS and using AWS code pipeline. Now, series of question arises here. The first question: how we are going to achieve this? How can we make sure that every release which is going to the production have an actual or proper security sign off? How can we make sure that each and every piece of code that is being written by your engineers or developer are getting scanned from security perspective, and not just from dash, not from a perspective of dynamic application security testing, but also from source code review, and not just from your source code review, but also from flexible security test cases. We will be seeing how we can achieve that if your organization is using CI/CD pipelines and using AWS code pipeline. Uh, a simple components of AWS code pipeline. What is AWS code pipeline? Is simply as continuous delivery service for your code that you can use to model or visualize or automate various steps that are involved in the release of the softwares. There are major three components in AWS code pipeline: AWS code commit, code build, and code deploy. Code commit is just a managed source control code repository service, just like you have GitHub, you have Bitbucket. Code build is actually the main component here. It's a fully managed continuous integration service that compiles your source code, runs tests, and produce a software package that are ready to be deployed. So code deploy, as the name suggests, it is a deployment service that automate the delivery, not the delivery, but automated deployment of your final product or feature to a variety of computing services. It can be your Amazon EC2, Fargate, Lambda, or even your on-premises servers. Now, this is simple architecture of AWS code pipeline. When you use AWS code pipeline as your CI/CD step, developer push a code. There's a webhook. I will be talking about what is the webhook, which triggers AWS code pipeline. AWS code pipeline in turn check out your source code, which been changed or modified. It runs its test, build, and prepare the package, which is ready to be deployed using AWS deploy. Now, in the earlier slide, previous slide said that webhook is. I will be talking about. I will be specifically emphasizing of what is this webhook. Now, this webhook is the actual heart of this continuous code hacking, which we are seeing here. What this webhook does is that because of this webhook, by using the GitHub webhook, AWS code pipeline comes to know that if there's any changes made to your code repositories, as soon as it learns that there's some change pushed in the code repository or there's some PR raised by your developer, it automatically runs your code pipeline. So the heart of this complete architecture are two. One is GitHub webhook and code build that I will be talking about next. So whenever any developer or any engineer raise any PR or make any change or of on any specific branch in your code repository, it triggers the code pipeline, which runs your steps that you have written. Now AWS code build. As I said, code build is another major component of your AWS code pipeline. It is what is AWS code build? I talk about how uh, how it brings how it impacts your complete code pipeline. It basically have different stages where you can write your tests and you can run it during the CI/CD pipeline. Instead of waiting security at the end of the development cycle, now you can include those security checks in the form of these builds. Or when I say build, it basically in the form of this build security steps. You can write those checks. You can write your manual tests. You can write standard checks within your AWS or within your CI/CD in the form of AWS build. Now this AWS build uh, consists of your build spec. Each code build project consists of your build specification. It is a build spec file, which is a collection of various commands and various setting in a YAML format. This is the actual file where you define your commands, where you define the scripts that needs to be done, or where you define the test that you are running on your code repository or on the changes that you have made to actually perform those security checks. Here is a very simple example of a code build spec file. Here is the build spec file of a Git secret, which is basically it scans for your secrets embedded or hard coded in your code repository. So whenever any developer or any engineer raise any PR, code pipe because of webhook, code pipeline started running and it runs this code build. I will be talking about how this code build is created. As I talk about, code build consists of three steps: pre-build, build, and post-build. Pre-build is basically where you set up all your dependencies. You download your dependencies, you put your scanners, and then there is a build stage where you run your scanners, where you actually parse your results. And then last stage of your code build spec file is post-build, where you call your Lambda or you basically consume those results. You can push those results to your Slack, to mail. So post build is where you consume those security results, security outcomes. Here you can see in the pre-build steps what I did. I have downloaded or I'm installing Git secrets. I am downloading all those scanner, putting dependencies, and setting up those tool in the pre-build steps. See, I have written pip3 install Turflug. Here I'm using Turflug for Git secret scanning. Then build stage where you actually run your tool or you run your security checks. And finally post build where you consume those results. So this is how a code build spec file looks like. A very simple file consists of three phases, three stages: pre-build, build, and post build. Now this complete continuous code hacking capabilities has numerous capabilities. Depends on you how much you want to utilize it. You can use it for your scanning your source code vulnerabilities. You can use this to perform dynamic application security testing. You can use it to scan your dependencies which you are using in a code repository for any unknown or known vulnerabilities, for any any old version that you're using that is out of development and that has some potential security issues. You can even detect secret in your PR, and you can even add your own capabilities. The most bright part of this complete framework is that it is uh, it is it is customizable. you can use your customized check. You can build your customized checks. You can write your own code. You can write your own checks. For example, I have written a Docker file linter test where it lint my Docker file. If developer or engineer has changed some or raise a PR which contains change in Docker file, it actually checks whether the Docker file is up to a security standard or not. You can build other checks also. For example, I built a check which is called check whitelist of base images. So it checks a Docker file and checks whether that Docker file is using the base image, which is a secure base image, or it is a whitelisted base image from my organization. I don't want my engineer to use a third-party base image which contain malware and getting deployed in my production environment. So you can build your own checks using this complete code hacking capability. Now, this is how the complete framework looks like. These are the happy developer setting, writing the code and pushing it to GitHub or Bitbucket, whatever code repository that you are using. Because of webhook, code pipeline comes to know that there is some changes developer has made in any of the branch or in any of the file project of GitHub or of your code repository, and it triggers the complete code pipeline. Code pipeline contains code build. The code build, now you have written various tests here. Dash, security scanning, Docker linter, or dependency scanning. As many tests that you have written, now they will run here. Then the next component in this complete framework is Lambda. After this test are runs, it invokes Lambda and push those and pass those security outcome from those code build steps, and send out the alerts over mail using SNS service, or it also push out those result to your AWS Security Hub or to Slack or to whatever means or channel communication channel you want to make your developer engineer aware that your code repository has contained some security vulnerabilities that you need to fix. Here is a screenshot of a secret scanning. So it is a output of a code build step. So when we see here, when we talk about code build, you can write multiple stages here, multiple checks. So here is the outcome of your code build, where you have written a code build spec for a secret scanning. So it tells you, you can even you can even blur those good secrets, because you don't want your good secrets to be lying in plain text in your logs. You can even make them blurred or not visible to your developers. Here is outcome of your dependency scanner. For dependency scanner, you can use open source OF's dependency scanner, and you can scan your code for multiple dependencies, insecure dependencies that you have in your code project. Docker linter, you can use Docker lint uh, to lint your Docker file and find out if that Docker file contains some steps which are not adhering to best security practices. The output will look like something like this. For example, you can see some in this particular Docker file which our developer has changed. It doesn't contain a tag, so it is saying that you should mention the tag, or you should mention the version which version of Docker image that you are using. Here is the static code scanning result. Here I use Sonar Cloud for source code scanning, and this is how the output looks like. Here is the dash scanning result. I use OF ZAP for performing the dash scanning of the final feature which is being pushed to the staging environment, or maybe whatever environment that you have. And you can see the kind of vulnerabilities it detects. For some particular release, it's saying that it has found cross-site scripting. Now, this code hack capabilities have multiple multiple advantage, multiple features. We have seen that number of checks, security checks that you can integrate, that you can actually write, or you can use some standard checks. You can use some standard open source tools, and you can write your own tool, or you can write your own checks. Apart from that, it provides a very beautiful feature of sharing those report. You can share those report or Slack or your mailbox or any communication channel that you want to share with your developers. You can even alert your engineers about the build. Your build has failed because your build contains some security loopholes that needs to be fixed before you are going to going to deploy it on the production environment. And finally, the main which the the most like part that I like, vulnerability management. You don't need to look for vulnerability management for any tool outside your native AWS services. You don't need to pull some or buy some tool, or buy some third-party tool or deploy it or install it. You can use AWS Security Hub for vulnerability management. Here, whatever findings that all the checks has find, it is actually being pushed to vulnerability management system using AWS Security Hub. So here I'm using AWS Security Hub for managing my all the vulnerabilities at a single place. I don't want to take a headache of using a third-party tool or using a non-native cloud-native AWS service. I'm using all the AWS native services here. But I'm for the vulnerability management. You can use AWS Security Hub. You can push your result to AWS Security Hub. You can track them. You can add labels, add tags. You can add severity and priorities to them also. This is how reporting over Slack channel looks like. This is unformatted. You can, as I said, this is completely in your hand. This is modular and customizable. You can customize as what you want. So this is how report over Slack channel look like when you use Sonar Cloud or Sonar Cube for security scanning, source code scanning. This is how build status over mailbox. You can alert your engineers that your build has failed. And as I said, this is unformatted. You can format it, and you can just give the information which is necessary for your developers to take action on. And this is vulnerability management over Security Hub. You can see all the vulnerabilities that are being found by this framework, by all the checks that I've written in code base, now pushed to AWS Security Hub with all the necessary information. What is the severity of this? What is the title? Which what is the priority of this, and where it has actually occurred. So you can use AWS Security Hub. You can leverage AWS Security Hub for management of your AWS security, for management of your security vulnerabilities at a single place. You can manage them. You can track them. You can track them for your user, and you can even share this dashboard or create rules for your AWS users to see or to track those vulnerabilities from here. Benefits, I've been talking about different benefits. Just a summary of it. It's a real time as you want because of webhook at the real time. When AWS code pipeline learns that they send some changes being made, it triggers your AWS code pipeline, triggers all the checks that you've written. And reporting, this is what management wants. This is what management looks out for. All the results and the status, you can communicate and share this around across different communication channels, whether it is Slack, mailboxes, or whatever that you are using. It is highly flexible, highly modular. As I said, all these checks are in the form of modules, so they are interdependent. They are non-dependent to each other. You can write as many security checks that you want in the form of module. You can just remove them if you don't want it. You can include them if you want it. It is completely automated. So automation is a real key. You don't need to do anything manual. You have created a complete framework, and all the things is happening automatically. Vulnerability management, all the vulnerabilities are being managed at a single place. You don't need to run here and there. You don't need to run around. You don't need to look for any third-party tool, Jira or any other tool for managing the security vulnerabilities. You can manage all those security vulnerabilities which being found during your during your release through at a single place, which is AWS Security Hub. A short demo of this. I've already recorded a demo for in the interest of time, and also I have a very bad history with live demo. So I've already recorded this. Let me show you a quick demo. Let me full screen this. See here, this is my code pipeline, which is DevSecOps. One developer has pushed some change in the code repository, and because of AWS, because of webhook, this get triggered. You can see in progress. Now, in turn, it will run all the security steps that I have written in the form of code build. So here are those all the security tests or security checks I've written in the form of AWS code build, dependency scans, SAS scan, dash scan, like this. So all this run parallelly. It's not like that you once one build steps is done, then and another build step will run. So all these are running parallelly. That is, it is fast, and it is as fast as you can think. So in order to see the output of any code build or any security check that you've written, you will just click on uh, the AWS code build here, and you can see the output here. You can go to a build run, and here is the output of that security check. So here it is a check of security Docker lint. You can see the kind of security alerts that it has found out, that using latest is prone to error. The developer is using a Docker file which is containing a base image, and which we don't have any kind of version. It is using the latest tag. So it is saying that you use a version to explicitly tell us that which version of Docker image that you are using. Similarly, you can check the other output. Here is the output of your source code vulnerability. For that, I use SonarQube, and you can even here is the dependency scan for all dependencies that you have in your code repository, for which I use a website. So all this code steps runs parallelly. When any changes have been made to your code repository, all the code build itself will run parallelly. And all of these are modular, all of these are automated. All the output will come here. You can even format it in a you can even you can format it in your own way. You can even truncate some information that you don't want to log, and you can consume those results in the way that you want to be that you want to consume. Share those results with your engineers over different communication channels. So this is about this short talk about how you can streamline security with shift left using cloud approach. If you are over AWS and using AWS code pipeline, it sums up my talk. And thanks for listening. If you have any question, you can reach out to my Twitter handle logic_1. You can check out my profile at logicbob.in, and you can even mail your queries, or if you want to be in touch in general, you can reach out to me at avinash.logicom@gmail.com. Thanks for being listening, and I'm also here for a while to take up your any question that you have. Thanks. Hack the planet.